Okay, students, let's look at another HC Verma question. That is a question regarding capacitor. It is required to construct a 10 microfarad capacitor which can be connected across a 200 volt battery. We have to make a 10 microfarad capacitor which could be connected across a 200 volt battery. Capacitance of 10 microfarad are available. We are given capacitors of 10 microfarad, but they can only withstand 50 volt. That is, they are giving you 10 microfarad capacitor, but the problem of this capacitor is they can withstand only 50 volt, and if they are connected to 200 volt, they'll collapse. Okay, design the combination which can yield the desired result by using 10 microfarad capacitor which can withstand 50 volt. We have to construct a setup which net capacitance should be 10 microfarad and the net potential should be 200 volt. Let's solve this. For that, let's look at the series combination of capacitor. If we are going back to the series combination of capacitor, let's say a V volt battery is connected to C1, C2, C3 capacitors which are connected in series. Then what will happen is there will be a potential difference across first capacitor, let it be V1, and the potential difference across second capacitor is V2, and the potential difference across the third capacitor is V3. And we have learned that the total potential is V1 plus V2 plus V3. That means in the series combination, the total potential is divided across each capacitor. And we might have learned total potential V is equal to what? NV dash, where V dash was potential over one capacitor if we are having n identical capacitors. You might have learned this formula also, where V dash is equal to V by N, where V dash is the potential over any one capacitor if n identical capacitors are connected in series. V is the total potential. Okay, therefore let's bear this in mind and let's construct. We are having 10 microfarad capacitor which can bear 50 volt. Therefore the total potential is 200 volt. Therefore, let me draw a 10 microfarad capacitor. Let this be our 10 microfarad capacitor, and it is of 10 microfarad and it can bear a potential of what? 50 volt. If I am constructing another 10 microfarad capacitor over here, it will also bear a voltage of 50 volt. Then likewise I am drawing two more. Okay, then you could see that this capacitor will also have a potential of 50 volt and this capacitor will also have a potential of 50 volt. The total potential will be what? 50 plus 50 plus 50 plus 50, that is equal to 200 volt. But all these capacitors are of 10 microfarad, and if this is also 10 10 10, then the total capacitance in series CS, we could write identical capacitors means we could write C by N. In this case it is 10 by 4. This total capacitance will be 10 by 4. The total capacitance will be 10 by 4 microfarad. But we require 10 microfarad. Then by adding one more branch, that is, if I am adding one more branch like this, we have learned in parallel combination the capacitance will add up. Therefore, this net capacitance, the net capacitance of this particular diagram, it was 10 by 4, and this will also have a capacitance of 10 by 4. Then you just imagine that we are having one more like this and one more like this. Then if we are connecting all these capacitors in parallel, what will happen is this one branch will have a capacitance of 10 by 4 microfarad. This branch will also have a capacitance of 10 by 4. That means the total capacitance will be 10 by 4 plus 10 by 4 plus 10 by 4 plus 10 by 4, that is equal to 4 into 10 by 4, that is equal to 10 microfarad. Therefore, by connecting 10 microfarad capacitors like this, the net capacitance of this arrangement is 10 microfarad, and it can have a potential of 200 volt. Okay, hope you have got an idea regarding this.